Imagine your web browser, not just as, a window showing you information, but as an intelligent assistant, one that actually acts on your behalf. Think about telling it, hey, plan my dream trip to Italy for next spring, find flights and hotels within my budget, and highlight some fantastic foodie tours. And it takes care of it. Or maybe synthesize these 10 complex research papers across different websites and draft a concise summary for my board reading, all with just a simple natural language command. This isn't science fiction anymore, It's the very real dawn of what we're calling the agentic browser. Welcome to the deep dive. This is where we unpack the most fascinating, really impactful shifts happening in our world. Today, we're diving headfirst into a transformation of the internet that feels, as profound as the shift from desktop to mobile. We're talking about the rise of the agentic browser. Now, you might have seen headlines, maybe even tried some early AI features in your browser, but today we're aiming to cut through the noise. Our goal is simple: give you a shortcut to being truly well-informed, explore what this pivotal change really means for you. We'll look at what agentic browsers are, what makes them tick, who's building them, and critically, the massive opportunities and, yes, the potential pitfalls they present. We're talking security, privacy, even the entire economy of the open web. We're about to uncover some genuinely unexpected shifts here. For this deep dive, we've pulled together an incredible stack of sources. We've got comprehensive reports like agentic browsers, evolution and future, some really incisive analyses from industry leaders like Kantar and A16s, plus crucial security insights from firms like Malwarebytes and Guardio, and specific details on groundbreaking new platforms like Perplexity, Comet, and OpenAI's Aura. We'll be extracting the most important nuggets of knowledge, really trying to help you understand this pivotal moment. Okay, let's unpack this fundamental shift because it really feels like our relationship with the internet is about to change in a profound way. We're talking about delegation at an entirely new level. Forget manually clicking tabs. This is different.
You've absolutely hit on a critical point there. This isn't just an incremental upgrade. It's not just, a new feature tacked onto something we already have. We're witnessing a complete inversion, really, of how we've used the web for decades. Control is shifting from direct human operation to, autonomous AI. For 30 years, the browser's been a passive window, right? It shows us what we ask to see. Now it's becoming a proactive partner that does what we intend. And this immediately invites a fundamental question. What does it truly mean for us, for you, to delegate our digital lives, our intentions, our actions to an intelligent agent that operates with this level of autonomy?
That's really the core of it, isn't it? For the longest time, the web browser has essentially been, a passive portal. We, the users, were always the navigators. We clicked, we typed, we decided every single step. But now, like you said, it's evolving, becoming an autonomous, goal-oriented collaborator. This isn't just about throwing some AI features into an existing browser and, calling it a day. No, this is a new class of software. It transforms the browser itself into an execution engine. Think about that for a second. It's like the web is suddenly becoming a programmable interface, which in turn positions the browser as maybe the next generation operating system. And when you have a shift like that, you ignite an entirely new platform war. So for us, as everyday internet users, what does this truly mean? It's not just about getting answers faster, is it? It's about getting things done. Like having a digital assistant that can actually use the internet on your behalf, not just search it or summarize a page you're already on.
Precisely. And the core definition of an agentic browser really clarifies this distinction. We're talking about an autonomous software system. It leverages AI agents to interpret your high-level goals, things you state quite simply. It then takes those goals, decomposes them, breaks them down into smaller sequential steps, and then executes these complex multi-step tasks across various websites. And the key part is without needing your continuous human intervention at every stage, the big shift. The browser transitions from being just a passive content rendering tool to becoming a goal-driven decision engine. And to illustrate this, let's contrast it with those AI-enhanced browsers we've seen emerge recently. Edge with Copilot, Chrome with Gemini features, they offer useful things, sure, like summarization or maybe conversational search. But you, the human, are still the operator. You're still driving. With an agentic browser, the AI itself becomes the operator. It takes the wheel for specific, complex tasks.
Okay, give us a concrete example then. What would this look like in practice for someone just planning an evening out?
Absolutely. So instead of you manually opening tabs, searching for restaurants, clicking through menus on different sites, comparing availability on booking platforms, and then filling out the form, you would simply tell the agent, find 3 good Italian restaurants near me for dinner next Tuesday around 7 p.m., check availability for 4 people, and book a table at the best option. And it would handle that entire workflow. It would search, filter based on your implied preferences, perhaps, interact with various booking sites, maybe even check reviews, and confirm the reservation, all based on your single high-level instruction. It completely removes that manual legwork, that tab-switching chaos.
Wow. Okay, this literally shifts the browser's core function, from showing information to doing things. One of our sources described it perfectly, I thought, as the web becoming a dynamic environment of action. That's a profound change in perspective, wouldn't you say?
It's an undeniable paradigm shift, and if we consider the broader implications here, this transforms every single website out there into essentially a programmable interface for an AI. It's effectively creating a lightweight, web-based operating system, one that manages resources and executes workflows on your behalf. And the immediate critical question this raises is, how deeply should we, trust a system that acts on our behalf with such a high degree of autonomy, especially when it's navigating, say, financial transactions or handling sensitive personal information? That trust factor is huge.
Yeah, absolutely. That trust factor is paramount. So how exactly are these agents engineered? How do they work to be trustworthy or at least effective? What are the core principles driving their autonomous actions?
Right. That brings us to the fundamental principles that make these agentic browsers tick. There are three key ones: autonomy, reasoning, and goal-directed action. The first, autonomy and agency, is really the defining characteristic. It's the ability to act without constant supervision. The agent plans, it initiates action, and it sees tasks through to completion. But critically, it's not brittle like older automation scripts. If it encounters an error, maybe a button on a website doesn't respond as expected, or the layout changes slightly, it adapts, it tries to self-correct, it finds another way to achieve the goal. It's intelligent, adaptive automation, not just blind repetition.
And this intelligence, this adaptability, it must be driven by some serious brains behind the operation, right?
Yeah, exactly. This intelligence comes from the reasoning and planning capability, the cognitive core of the agent. This is powered by large language models, LLMs, and it mimics human problem solving through a multi-stage process. First, there's intent interpretation. The agent has to understand your high-level requests, like plan a trip to Paris. Then comes task decomposition. It breaks that big goal down into smaller logical steps. Search flights, find hotels near the city center, check train options, look for museum passes, etc. Then, crucially, it performs website analysis. This is where it reads the page's underlying structure, the document object model, or DOM. It identifies interactive elements like forms, buttons, data tables, links. It understands the architecture, not just how it looks visually to us. Based on that structural understanding, it moves into the action planning phase. It creates a detailed, step-by-step execution plan. First, go to this URL. Then find the form field labeled destination and enter Paris. Then click the button with ID search flights, that kind of thing. Finally, there's execution and validation. The agent carries out the plan step by step and continuously confirms that its actions produce the intended outcome. Did the search run? Did the booking get confirmed? This whole process is a reasoning action cycle. The agent reasons, acts, observes the result, reasons again, acts again until your overall goal is achieved.
That constant validation and self-correction loop, that sounds truly key to making it robust. And all of this effort is geared towards goal-directed behavior. Unlike, say, a reactive AI that just answers a specific question or translates a sentence. Agentic systems are all about achieving complex multi-step goals, sometimes over a long period. You specify the desired end state. I want to book a trip to Paris for these dates within this budget, and the agent is responsible for navigating the entire path to get there. It might even dynamically adjust for changes along the way, like if flight prices fluctuate significantly while it's building your itinerary. It acts with a purposeful intent, not just a reactive response. Okay, to truly grasp the magnitude of this shift, maybe let's look at the evolutionary journey of the browser itself. Our sources map it out in three pretty distinct stages, and the contrast is revealing. Stage 1, traditional browsers. Think back to early Chrome, Firefox, Netscape even. These were passive tools, essentially. You, the human, were the sole operator, manually navigating, clicking, typing every single thing. The browser's job was simple. Render the pages you told it to. That was it.
Then came stage 2. AI-enhanced browsers. This is more recent. Here, AI started acting as an assistive tool. We mentioned examples like Microsoft Edge with Copilot or Chrome with its Gemini integration. These browsers offer things like page summarization, maybe generating some text, or handling conversational search queries. But the user is still fundamentally in control. The AI augments your manual browsing, it provides information, maybe drafts an email, but it doesn't take action across multiple sites on your behalf to complete a complex task. It's a helper, not an autonomous actor.
And now, we're firmly entering stage 3, agentic browsers. This is where the AI becomes an autonomous agent. It becomes the primary operator for certain tasks. You, the user, delegate an entire workflow. Book that trip. Research this topic. The interaction shifts fundamentally. We move from direct manipulation of a graphical user interface, a GUI, clicking buttons and menus, to the delegation of intent via a linguistic user interface, an LUI. You speak or type your goal, the agent figures out how to act on it. Our sources provide a great comparison table that really crystallizes the key differentiators between these stages. It makes the jump very clear.
That comparison certainly highlights the dramatic shift, doesn't it? With a traditional browser, the main function is simply rendering pages. That's its job. With AI-enhanced browsers, it shifts to answering questions or providing assistance. It helps you while you browse. But with an agentic browser, its primary function is to autonomously execute complex, multi-step web-based workflows. User input consequently goes from high, you do everything, to medium, you guide the assistant, to low, you state the goal. Autonomy level obviously goes from none to limited assistance to high autonomy for the agent. And task complexity moves from simple page viewing to maybe moderate tasks like summarizing to truly complex multi-site operations handled end-to-end. Critically, workflow automation transforms from non-existent to maybe limited single-site actions to full end-to-end execution across the web.
It's a pretty stark comparison when you lay it out like that. Really stark. This isn't just about a new feature set. It's a fundamentally new way of interacting with the entire digital world. It feels like it's redefining the relationship between us and the internet, potentially.
It absolutely is. And this shift, it isn't merely about convenience, though that's part of the appeal. It fundamentally positions the browser as the next dominant operating system. The reports we analyzed explicitly say this is likely to lead to a new OS war, but this time fought on the open web itself. So for you, the listener, this means the browser could become the primary platform for running tasks and managing complex workflows. It might potentially replace the need for many separate, disparate applications you use today. It's a consolidation of digital power and capability that could reshape our daily digital interactions quite significantly.
Okay, so the theoretical potential of this agentic era, it really burst into the mainstream with one specific product launch, didn't it? Perplexity AI's Comet. This wasn't just another incremental update from an existing player. It felt like a market-defining moment. It showed everyone what an agentic browser could actually do. Tell us about its launch. What made it so impactful?
Indeed. Perplexity AI officially launched Comet back on July 9, 2025. And they made a very deliberate statement with its positioning. They billed it as the world's first AI-native browser. They used slogans emphasizing a move from navigation to cognition and, crucially, from answers to action. It wasn't just about information retrieval anymore. Their initial go-to-market strategy was also quite notable. It was launched exclusively for Perplexity Max subscribers, and that tier came with a hefty price tag. $200 per month.
Wow, $200 a month, that's steep.
It is, but it was a calculated move. The rationale was to target power users first, professionals like analysts, developers, researchers, people for whom the potential productivity gains could easily justify that cost. This approach achieved two things. It built prestige around the product, and perhaps more importantly, it allowed Perplexity to gather high-quality, detailed feedback from users who would really push the technology to its limits.
Perplexity really made a bold move there, didn't
Right.
they? They weren't just adding AI features. They were essentially saying, this is the browser.
Yeah.
And that exclusive high-tier launch, yeah, it seems brilliant for building that initial buzz and getting that crucial feedback loop going.
Absolutely. This strategy allowed them to validate the market demand at the high end and iterate rapidly based on intense usage patterns. The launch was widely interpreted across the tech industry as the opening salvo in Browser Wars 2.0. It directly challenged Google Chrome's long-standing dominance, not by competing on traditional browser features, but by shifting the battleground to intelligence and autonomy. It signaled a new era had truly begun.
Okay, so let's dive into Comet's architecture and capabilities, because it sounds like a fascinating example of this new breed. It's built on Chromium, right?
Yeah.
The same open source project that powers Chrome and Edge. That seems like a smart foundational choice for compatibility.
Exactly. That Chromium foundation is crucial. It ensures immediate compatibility with countless existing Chrome extensions, bookmarks, user settings. Basically, it dramatically lowers the friction for adoption. People don't have to completely relearn everything or abandon their existing tools. But the real innovation lies layered on top of that. Its hybrid AI model. Comet intelligently balances the need for powerful cloud-based AI models with user concerns about privacy and speed. Simple tasks, and especially the processing of sensitive user context like understanding what's in your currently open tabs, are handled locally right there on your machine. This minimizes latency, makes it feel faster, and critically keeps that potentially sensitive data on your device. However, for the really complex reasoning, planning, and generation tasks, the stuff that demands immense computational power, Comet intelligently sends queries to Perplexity's cloud infrastructure. This architecture represents a really pragmatic engineering solution. It tackles that central tension in AI between raw capability and confidentiality. It tries to give you the best of both worlds. The power of the cloud when needed, but local processing for speed and privacy where possible. It's a model we'll likely see become an industry standard for agentic systems.
So it's not just an AI working in there. It's like a whole team of AIs working together behind the scenes. Our sources mention a multi-LLM orchestration layer. What does that actually mean for how it performs tasks? How does that work?
That's a great way to put it. Comet doesn't rely on a single monolithic large language model. Instead, it has a sophisticated modular orchestration layer. Think of it as an intelligent router. It dynamically routes user queries or even subparts of a complex query to the most suitable LLM for that specific job. For instance, our sources suggest it might leverage something like GPT-4 Turbo for complex reasoning and planning steps. Then perhaps use Claude 3 for its known strengths in real-time web scraping or generating long-form summaries. And potentially use Perplexity's own proprietary models for tasks like fact-checking, ensuring accuracy, and providing proper citations. It's about picking the right tool, the right specialized AI model for each specific part of the job. This allows for much more nuanced, effective, and potentially efficient task execution compared to relying on one generalist model for everything. Another critical technical capability underpinning Comet's effectiveness is its DOM awareness. The agent possesses a real-time understanding of a web page's document object model. Think of the DOM as the hidden skeletal structure of a web page. It's the organized map of all the headings, forms, buttons, links, tables, paragraphs, everything. It's not just about how the page looks visually. By reading this underlying structure, the agent understands the page's architecture and how its components relate to each other. This is what enables it to interact with websites reliably and precisely, identifying the right button to click or the correct form field to fill. It perceives the web as a truly machine-readable environment, not just pixels on a screen.
That makes perfect sense. Understanding the structure is key to interacting with it reliably. So how do you actually use this thing? What's the user experience like? And what kind of practical things can it actually do for us? Let's get into the specifics.
The primary interface is the Comet Assistant. This is typically presented as a persistent agent, often housed in a sidebar within the browser window. It's designed to be constantly perceiving your current browsing session, what tabs you have open, what page you're looking at, and ready to act upon that context. And this is where the agentic capabilities truly shine. You can delegate entire complex workflows. For e-commerce, imagine saying, find me a good quality, reasonably priced, sensitive skin cleanser. Compare options across Amazon, Sephora, and maybe this niche skincare site I have open. Validate the user reviews for authenticity, and if it meets my criteria, proceed to check out using my stored details. Or for productivity. Scan my calendar for tomorrow's meetings, find all relevant emails and documents related to those meetings in my inbox and Google Drive. Then prepare a concise briefing summary document for me. And for research, something like, synthesize the key arguments, methodologies, and conclusions from these 10 open tabs containing academic papers on quantum computing. Draft a report summarizing the current state of the field based on these sources.
Wow. Imagine the sheer amount of time this could save. Delegating entire workflows like that, instead of constantly switching between tabs and applications, copying and pasting, it's a game changer for productivity.
Absolutely. And underpinning this capability is the assistant's impressive contextual memory. It maintains a persistent memory, often using a vector database, which stores your browsing history, the state of various applications or tasks it's working on, and critically, your learned preferences and habits over time. This allows for incredibly fluid conversational interaction. The assistant can recall the original context of a task or conversation even hours later, or after you've navigated through dozens of other tabs. There's even a specific feature mentioned, the @tab feature. This allows you to explicitly direct the agent's focus to specific open tabs when asking a question or giving a command. For example, summarize the main points from @tab 3 and @tab 5. This ensures highly relevant, in-context responses and actions.
That sounds incredibly powerful, almost like having an entire research department or a personal assistant living inside your browser. Have you seen any early examples or mentions of how this could genuinely transform really complex projects beyond just booking dinner?
Well, looking ahead, Perplexity has even detailed plans for a future capability called swarms mode.
Hmm.
This envisions a true multi-agent system where, for a particularly complex query, the browser could deploy a whole team of specialized AI agents working in parallel. For example, you might ask a complex research question. One agent could specialize in searching academic literature databases. Another could scan recent news articles and reports. A third might focus on analyzing financial data or market trends. And then a final synthesizer agent would take all their findings and integrate them into a single comprehensive response. It's a truly collaborative multi-agent architecture planned for a consumer product. That could dramatically accelerate anything from market research and competitive analysis to writing complex scientific reviews. The potential is immense.
Okay, now, as groundbreaking and exciting as Comet sounds, its initial release wasn't without its significant bumps in the road. Our sources highlight some pretty serious early security vulnerabilities and user trust deficits. Independent analyses apparently revealed Comet was launched with inadequate security safeguards. That's a huge red flag, isn't it? It really underscores how a powerful tool like this can become a serious liability if not secured properly from day one.
It absolutely does. And it shines a harsh light on the novel risks these autonomous systems introduce. The security firm Guardio, for instance, conducted some controlled experiments shortly after Comet's launch, and they revealed some alarming vulnerabilities. In one particularly striking example, they instructed Comet to purchase an item while the browser was navigated to a meticulously crafted fake Walmart website. The agent proceeded to scan the fraudulent site, identify the product, navigate to the fake checkout page, autofill stored credit card and shipping information, and actually complete the purchase without any human confirmation step. This represented a critical failure in the agent's ability to validate the legitimacy of a website before performing a highly sensitive financial transaction.
That's terrifying. An agent autonomously completing a purchase on a fake site using your saved credentials without you even double-checking. Wow. And it gets worse, right? The agent was also susceptible to phishing attacks.
Yes. In another test, the agent was presented with a fake email notification designed to look like it came from a legitimate bank. The agent clicked the malicious link embedded in the email, loaded the attacker's phishing page, designed to steal login credentials, and then actually prompted the user to enter their bank login details on the fake page. In effect, the agent was tricked into actively aiding the phishing attack, leveraging the user's trust in the assistant itself. The idea of your AI assistant inadvertently helping an attacker steal your passwords is, well, deeply unsettling, it is. But perhaps the most severe and certainly the most novel vulnerability discovered was Comet's susceptibility to what's called indirect prompt injection. This is a fundamentally new type of attack vector specific to AI agents. Malicious instructions are embedded within third-party content that the agent is asked to process, maybe hidden within the text of a web page it's summarizing, inside a PDF it's analyzing, or even buried in a comment on a social media forum. The crucial part is that these instructions are often invisible to the human user. Think white text on a white background, or instructions hidden in metadata. When the agent processes this raw, unsanitized content, it currently lacks the ability to reliably distinguish between trusted instructions from you, the user, and these untrusted malicious instructions smuggled in from the web. Consequently, it might execute these hidden commands. This could lead to anything from exfiltrating sensitive data from your other open tabs to making unauthorized purchases, installing malware, or sending phishing emails from your account. Indirect prompt injection fundamentally breaks traditional cybersecurity models. Those models are largely predicated on a human user interpreting content, judging its trustworthiness, and deciding whether to click or act. With an agent acting autonomously, that human judgment filter is removed or bypassed. So the critical question security researchers are grappling with is, how do we build trust? How do we secure systems that can be so easily manipulated by commands you can't even see? It's a profound challenge.
Beyond these critical security flaws, there were also early reports of just basic reliability issues, weren't there? Things going slightly wrong. For instance, one user apparently asked the browser to book a restaurant reservation for a specific contact named in the prompt, but the agent somehow got confused and ended up emailing a completely different person from the user's address book about the booking. These kinds of failures, even if they're infrequent, they severely undermine the user trust that's absolutely necessary before people feel comfortable delegating important high-stakes tasks to these agents. You need to know it's going to get it right.
Absolutely. These early stumbles, both in security and reliability, underscore the monumental engineering challenge involved in making these complex autonomous systems truly robust, safe, and dependable. It's not easy. But amidst navigating these initial challenges, Perplexity also unveiled a truly forward-thinking and perhaps necessary move on the business side: business model innovation through the Comet Plus Publisher program. Perplexity clearly recognized that the inherent zero-click nature of many agentic interactions, where the agent finds information and synthesizes an answer without the user needing to visit the source websites, poses an existential threat to the traditional ad-supported model that funds most content creators on the open web.
Right, this is a genuinely innovative approach they're taking. It seems like they're trying to proactively build a bridge between the old web economy based on clicks and page views and the new one driven by AI agents. Their solution, Comet Plus, is a subscription tier around $5 per month as reported, where a remarkable 80% of that revenue is earmarked for distribution directly back to participating publishers whose content is used by the system.
Yes, and the real innovation lies in the tripartite compensation model they proposed. It's specifically designed for this emerging AI era. Publishers are compensated not just for one thing, but for three distinct types of value they provide. First, human traffic, which is the traditional model, direct visits from human users clicking links. That still counts. Second, index traffic. This is compensation for when a publisher's content is used, analyzed, and explicitly cited in an AI-generated answer or summary presented within the Perplexity interface itself. And third, critically, agent traffic. This is compensation for when the Comet Assistant autonomously accesses and utilizes a publisher's content behind the scenes as part of executing a complex task on behalf of the user, even if the user never directly sees or visits that publisher site during the process. This tripartite model is really one of the first significant attempts in the industry to formally recognize and assign monetary value to the crucial role that high-quality content plays in training, informing, and enabling AI agents, even when that interaction doesn't result in a traditional page view or click. It's a critical experiment, an attempt to create a more sustainable economic ecosystem for the Agentic Web by trying to align the interests of the AI platform with those of the content creators it fundamentally relies on. What's fascinating here is how it tries to solve that economic tension proactively.
So Perplexity's Comet definitely made a massive splash. But as you said, it didn't happen in a vacuum. The market was already buzzing, and Comet's launch really forced everyone else, especially the big players, to accelerate their own plans. This has absolutely kicked off what many are calling Browser Wars 2.0. Let's look first at how the incumbents, the giants like Google and Microsoft, are responding. Their strategy seems, well, more evolutionary perhaps. They're leveraging their vast resources, their huge existing user bases, and their deep market penetration to integrate agentic capabilities gradually. They seem to be easing their massive audiences into this new paradigm, rather than asking them to make a radical switch to a completely new product.
You've characterized their strategy perfectly. Google, for instance, with its commanding, 70% share of the mobile browser market alone, holds a formidable position. Their approach appears to be about deeply weaving agentic features into their vast existing ecosystem. We're hearing about Project Mariner, which sources describe as Google's dedicated internal initiative specifically focused on developing an agent capable of autonomously clicking through websites and completing complex tasks like navigating checkout flows or filling out forms. This seems like a natural extension of capabilities we're already starting to see surface in things like AI mode, which used to be called AI overviews in Google search. That feature already synthesizes answers from multiple sources, a clear foundational step toward full agentic behavior where the AI takes the next step and acts on that synthesis. And Google's unparalleled strategic advantage, of course, lies in its sprawling ecosystem. Imagine integrating its agents seamlessly with your Gmail, your calendar, maps, your workspace documents. The potential for truly seamless, context-aware assistance is enormous.
Right. And Microsoft is pursuing a very similar strategy with its Edge browser, isn't it? Integrating agentic features primarily through Copilot. Copilot is often positioned more as a work-focused assistant. It can already read open tabs, with user consent, importantly, and seems on a clear path towards enabling delegated actions like making travel reservations or, crucially for Microsoft, managing complex corporate workflows. Their deep integration with the Microsoft 365 Suite Outlook, Teams, Word, Excel, PowerPoint makes Copilot a potentially incredibly powerful contender, especially in the lucrative enterprise market. So yeah, they're definitely not sitting still, are they? These giants are clearly adapting their existing empires, leveraging their installed base, rather than trying to build entirely new ones from scratch. They're banking on their massive user numbers and existing infrastructure.
That's exactly right. Their strategy is fundamentally about leveraging existing user trust, familiar interfaces, and deep infrastructural advantages to gradually introduce these powerful new agentic capabilities. The really interesting strategic question here is, Can this kind of evolutionary approach, carefully building upon established platforms, truly compete in the long run with the revolutionary AI native designs coming from more agile challengers? Or will the incumbents, despite their resources, always be playing catch up to the innovators who can start fresh, unburdened by legacy systems? It's a classic innovator's dilemma scenario playing out again.
That's the tension, isn't it? Because then you have the challengers. Companies like OpenAI, the browser company, and a whole host of other startups and newer players, they're taking a much more revolutionary approach. They're building AI-native browsers, often from the ground up, explicitly aiming to leapfrog the incumbents by offering entirely new user experiences designed specifically for this agentic paradigm. They aren't tied to the old ways.
OpenAI, naturally, as a leader in the foundational AI models themselves, is a particularly anticipated player in this space. They're reportedly developing their own Chromium-based browser, currently codenamed Aura. This browser is expected to feature a powerful, deeply integrated AI agent known internally as Operator. Leaked details and industry speculation suggest Aura might represent a radical departure in user interface design. There are reports they plan to replace the traditional tab-based browsing metaphor with a more fluid, chat-centric interface, making conversational interaction the primary way users engage with the browser and the web. Operator is expected to be deeply integrated with ChatGPT's capabilities and designed specifically to automate tasks like form filling, support real-time transactions, and manage complex, multi-step workflows initiated through natural language.
Very interesting. Then there's the browser company, already known for its quite innovative Arc browser. They've launched Dia, which they explicitly call an AI-first browser, currently in beta as of June 2025. Dia seems to be taking a different approach to the interface. It reportedly transforms the traditional URL address bar into a versatile natural language command line, so you can use that single input field to search, navigate, or issue commands directly to the AI agent. A key feature mentioned is the ability for users to create customizable skills, which sound like user-defined automation scripts or workflows that the agent can learn and execute. It also apparently includes a tab-aware chatbot similar to Comet's assistant and emphasizes user privacy through measures like local data encryption. This is where the innovation really shines, I think. These challengers aren't constrained by decades of legacy code or user expectations. They're truly rethinking the browser from the ground up for an AI-powered future.
And the market is expanding even further with other interesting players, each seemingly carving out a distinct niche or focus. You have Brave, for example, which is known for its strong privacy focus. They're reportedly integrating agentic features while aiming to maintain that core commitment to data protection. The Sigma AI browser is another one differentiating explicitly on security, claiming things like end-to-end encryption for agent interactions. Fellow.ai seems to be specializing specifically in automating complex, multi-step business workflows within the browser. And Genspark appears to be targeting the academic and research communities, focusing on agentic capabilities tailored to tasks like finding and downloading relevant papers, synthesizing information across multiple studies, and maybe even helping draft literature reviews. The specialization is starting already.
But it's not just about big companies or venture-backed startups, is it? There's also a really vibrant open-source vanguard emerging. Their focus seems less on building a single dominant consumer product and more on providing transparent, customizable, and often privacy-preserving building blocks that empower developers and users to create their own agentic experiences.
Indeed. This open source movement is critical. You have projects like BrowserOS, which boldly positions itself as a full AI operating system for the web. It's completely open source, built on Chromium for compatibility, but designed with a privacy-first ethos from the start. It allows users to interact via natural language commands. Crucially, it supports a wide range of different LLMs, including, importantly, the ability to run models locally on the user's own machine via frameworks like Llama. This ensures that sensitive user data and interaction history never have to leave the device, which is a major privacy advantage.
And for those who maybe don't want to switch their entire browser, there's Nano Browser. This sounds really interesting. It's described as a lightweight, open-source Chrome extension. So it essentially retrofits agentic capabilities onto your existing Chrome installation. You don't have to ditch the browser you're used to. It apparently runs entirely locally on your machine, uses the individual's own API keys for connecting to external LLM services, giving the user control over costs and model choice, and employs a sophisticated internal architecture, they call it a planner, navigator, validator system, to break down and execute tasks reliably. It really seems to democratize access to this agentic technology, allowing tech-savvy users to build, customize, and control their own agents within their familiar browser environment.
And alongside these user-facing projects, we're also seeing the emergence of dedicated developer-focused frameworks designed specifically for building resilient web agents. Stagehand, for example, is a library that's compatible with existing automation tools like Playwright. It infuses those automation scripts with LLM capabilities. This allows the scripts to intelligently adapt in real time if a website's layout changes slightly, overcoming the notorious brittleness of traditional web automation that breaks easily. Similarly, Browser Use, which is a Y Combinator-backed project, provides a visual no-code interface aimed at teams. It allows them to easily define and automate repetitive browser-based tasks without needing deep coding expertise. This parallel ecosystem, this open source movement emphasizing user control, transparency, interoperability, and developer empowerment, it's really significant. This bifurcation we're seeing between the highly integrated, often closed systems from the big tech players and these more open, modular, community-driven frameworks, it definitely mirrors previous platform wars, like the classic iOS versus Android battle. It suggests an underlying tension between the convenience of integrated systems and the flexibility and control offered by open frameworks. So the really important question for you, the listener, becomes, which approach will ultimately earn your trust? Which paradigm do you think will become dominant for the agentic web?
That's a critical question indeed. And the diversity of approaches really becomes crystal clear when you look at the comparative analysis our sources provide, breaking down the different players based on their UI/UX, their level of automation, and their primary target audience. You can really see the variety. You've got Perplexity Comet with its hybrid UI, clearly targeting power users with a premium subscription model. Then you have OpenAI's Operator Aura, reportedly aiming for a chat-centric interface for mainstream consumers, likely also via subscription. The browser company's Daya uses that innovative AI-infused address bar, seemingly targeting creative professionals and prosumers, with its business model perhaps still evolving. Google's Project Mariner represents the incumbent strategy, integrating agentic features into the traditional browser UI for the mass market and enterprise, monetized through advertising and potential transaction fees. Then Browser OS, with its focus on natural language interaction, targets developers and the highly privacy-conscious, operating on an open-source model. And finally, Nano Browser, being an extension, appeals to tech-savvy users who want to enhance their existing Chrome setup, again, open source. So you can really see a future taking shape where there might be an agentic browser or an agentic enhancement tailored for almost every type of user and every type of task. Certainly not shaping up to be a one-size-fits-all world anymore.
Okay, so to truly appreciate the capabilities and also the complexities of these agentic browsers, we really need to look under the hood. These aren't just sophisticated chatbots with a browser window attached. They are intricate systems built upon a complex, multi-layered technology stack. At the very heart of it all, providing the brains of the operation, is the role of multimodal and orchestrated LLMs. The reasoning engine is the cognitive core. It's powered by these large language models, and it's responsible for everything from interpreting your initial intent to decomposing the problem into steps to planning the sequence of actions needed.
Right, and as we heard with Perplexity Comet, the most advanced systems don't just rely on a single monolithic LM anymore. They typically use an orchestration layer. This layer acts like an intelligent conductor, dynamically routing different subtasks or aspects of a query to specialized models that are best suited for that particular job. Perplexity, for instance, reportedly uses models from OpenAI, Anthropic, and its own proprietary systems for distinct parts of a workflow. Maybe one for reasoning, another for web scraping, a third for fact-checking.
Exactly. And furthermore, the industry is rapidly moving beyond just text-based models towards multimodal models. Think of things like GPT-4o or Google's Gemini models. These advanced models can process and reason about multiple types of information simultaneously. This is a crucial leap. It means they can analyze not only the textual content of a web page by parsing its underlying HTML code and BOM structure, but also its visual layout, often by processing screenshots or rendering the page visually. Think of it like this. The agent doesn't just read the page anymore. It effectively sees the page, much like a human does. This visual comprehension capability enables far more robust and reliable interaction, especially with modern, dynamic, JavaScript-heavy websites where layout is complex. It helps interpret graphical elements like charts or diagrams, and it can even potentially help tackle challenges like solving visual capti-sudas. It's a huge step towards more human-like web understanding.
Okay, so once the brain, the reasoning engine, has formulated a plan based on understanding the request and the web page, the agent needs to actually act on that plan. This brings us to the hands of the agent, the browser control layers, and the execution environments. How does the agent actually do things within a browser window? Click buttons, type text.
Right. The agent acts by issuing commands through specialized APIs, application programming interfaces, that allow programmatic control over a web browser. These APIs expose commands like navigate to this URL, find the element with this ID and click it, or locate the form field named username and enter this text. Now, while traditional web automation libraries like Playwright and Puppeteer, often used for website testing, can be used for this, their communication mechanism can sometimes introduce latency, which isn't ideal for highly interactive, real-time agentic tasks. So the emerging standard, especially for high-performance agentic systems built on Chromium-based browsers, which includes Chrome, Edge, Brave, Arc, and others, is the Chrome DevTools Protocol, or CDP. CDP provides a direct, low-latency, and highly granular communication channel right into the browser's core rendering engine. It allows for very fine-grained control and monitoring, which is why it's often preferred for building responsive and sophisticated browser agents, like those developed by BrowserUse, for example. And these control layers typically operate on what's called a headless browser. You should imagine a full, modern web browser like Chrome, but running entirely in the background without a visible graphical user interface, GUI. It has all the capabilities rendering pages, executing JavaScript, managing cookies, but it does so invisibly. These headless browser instances are often provisioned and run within secure, isolated execution environments called sandboxes. These can run on your local machine, but more commonly for scalable, commercial applications, they run in the cloud. In fact, we're seeing companies like BrowserBase emerge, specializing in providing browsers as a service infrastructure specifically optimized for hosting and managing these headless browser instances at scale for AI agent workloads.
So it's not just a fancy chatbot talking to you. It's a chatbot that literally has its own dedicated invisible browser instance, maybe even multiple instances, running somewhere, ready to go out and do things on the web as your digital proxy. That's a huge architectural shift from what we typically think of as AI assistants.
It absolutely is. It's AI coupled with dedicated, controllable execution environments. And connecting these brains, the LLMs, to the hands, the browser control layer, is what we can think of as the nervous system of the agentic stack. This comprises the orchestration frameworks and the crucial memory systems. Orchestration frameworks are essentially the software skeletons that manage the overall agentic workflow from start to finish. They maintain the state of a complex multi-step task, they coordinate collaboration if multiple specialized agents are involved, and they manage the sequence of calls to different tools like invoking the browser control API, querying a database, or calling another external service API. Prominent examples of these frameworks include Microsoft's AutoGen, which is specifically designed for building applications with multiple collaborating AI agents, and the popular LangChain library, and its more recent successor, LangGraph, which provide tools and abstractions for building complex, stateful, and potentially branching agentic workflows.
Okay, and for an agent to be truly intelligent and useful over time, not just a one-shot tool, it needs memory, right? How do these systems remember things about us, our preferences, and the tasks they're working on?
Memory is absolutely critical for intelligence and personalization. Memory systems are what allow agents to maintain context during a task, learn from past interactions, and personalize their behavior over time to become more helpful. We can generally think about two types of memory in these systems. Short-term memory, which maintains the context within a single ongoing task or conversation. It remembers the intermediate steps taken, the information gathered so far, the immediate goal. It's like the agent's working scratchpad. And then there's long-term memory, which persists across multiple sessions, potentially over days, weeks, or longer. This is where the agent stores learned user preferences, past successful and unsuccessful task executions, interaction history. Basically, it's how the agent gets to know you over time, becomes more attuned to your specific needs and habits. Technically, these memory systems, especially long-term memory, often rely on vector databases. Think of database technologies like Pinecone, Weaviate, or ChromaDB. These specialized databases store information not as raw text, but as numerical representations called embeddings. These embeddings capture the semantic meaning of the information, allowing the agent to perform incredibly fast and relevant searches based on meaning, not just keywords. So it can quickly retrieve the most relevant pieces of past knowledge or user preferences when tackling a new related task.
That makes sense.
Yeah.
But it also brings up that privacy question again, doesn't it?
It absolutely does. This raises an important question. How much memory do we actually want these agents to have about us? The more they remember, the more personalized, proactive, and genuinely helpful they can potentially become. But at the same time, the more they remember, the more sensitive personal data is being stored and processed, amplifying the privacy considerations and potential risks if that data is ever compromised or misused. It's a fundamental trade-off we need to navigate carefully.
Definitely a trade-off. Now, to really understand how all these pieces fit together, the models, the execution, the memory, the tools, and critically, where the real strategic value lies in this emerging ecosystem, we need to look at the 7-layer agentic AI stack that some analysts are proposing. It's not just one thing, but a whole symphony of technologies working together. This is where we really pull back the curtain on how these incredibly complex systems are built and where the competitive battlegrounds might be.
Exactly. Let's quickly dissect each layer as presented in our sources and consider its strategic importance in this new landscape. Layer 1. Foundation model infrastructure. This is the base layer. It includes the core AI models themselves from OpenAI, Anthropic, Google, etc., the underlying cloud compute infrastructure, AWS, Azure, GCP, and the APIs used to access them. The consensus is that the strategic importance here is now relatively low, almost becoming commoditized. Powerful foundation models are becoming increasingly accessible and somewhat interchangeable. Layer 2. Agent runtime and infrastructure. This is the operational environment where agents actually execute their tasks. It includes containerization technologies like Docker, Kubernetes, specialized memory systems, vector databases like Zep or Pinecone, and secure sandboxing environments like Modal or Replicate. Strategic importance here is medium. Differentiation comes from performance, scalability, efficient state handling, and robust security at this crucial execution layer. Layer 3. Protocol and interoperability. This layer encompasses the standards and protocols that allow agents to communicate with each other and with external tools like MCP, A2A, ACP, ANP, which we'll touch on later. Strategic importance is likely low in the long run, potentially commoditized. The value here lies in broad adoption, open standards to enable an interoperable ecosystem rather than proprietary control. Layer 4, orchestration. This layer manages the complex coordination between multiple agents or tools, handling the overall workflow logic using frameworks like Microsoft's Autogen, LangChain LangGraph, or Crew AI. Strategic importance is medium. These frameworks are key for building sophisticated agents, but many are open source, which can limit long-term defensibility based on the framework alone. Layer 5, tooling and enrichment. This is where agents connect to the outside world to actually do things. It includes tools for browser automation, like browser use, data extraction services, like Bright Data, specialized search APIs, like Sirpapi, or platforms for invoking other business workflows, like Zapier. Strategic importance here is high. Reliably connecting the AI agent to the messy, unpredictable real world requires deep domain expertise and complex, robust integrations. Building trustworthy and effective tools for agents is a strong differentiator. Layer 6, applications. This is the user-facing layer, the agentic browsers themselves, Perplexity, Comet, Dia, or specific AI copilots embedded in other applications, like GitHub Copilot. Counterintuitively, perhaps, the strategic importance here is now often rated as potentially low. This layer is becoming crowded quickly, and defensibility might be challenging unless tightly integrated vertically or benefiting from unique data access moats. Layer 7, observability and governance. This crucial top layer provides the monitoring, evaluation, security tooling, safety guardrails, and deployment infrastructure needed to manage agents responsibly and effectively, especially in enterprise contexts. Think tools like Langfuse, Datadog for AI, Lakera for security, Immuta for data governance, or MLflow for deployment. Strategic importance here is high. As agents become more autonomous and powerful, the need for robust monitoring, control, security, and governance becomes absolutely paramount, creating significant value opportunities.
Wow, that's a fascinating breakdown.
What's really fascinating here is the apparent inversion of the traditional software value chain that this stack suggests. Historically, huge value was captured at the application layer, layer 6. Now it seems the foundational models, layer 1, and even the user-facing applications themselves, layer 6, are rapidly commoditizing or becoming highly competitive. The real defensible strategic value appears to be migrating upwards towards the middle and top layers. The critical enabling infrastructure for security and governance, layer 7, the specialized tooling needed to connect agents to the real world reliably, layer 5, and perhaps the optimized runtime environments, layer 2. So this raises a critical question, especially for investors and strategists looking at this space. Where are the truly durable opportunities in this new ecosystem? It's clearly not just about building yet another AI application or chatbot. It's increasingly about building the critical infrastructure that enables the entire agentic ecosystem to function safely, reliably, and effectively.
That inversion of the value chain is a massive insight. But as with any powerful new technology, especially one that acts autonomously on our behalf, there are profound ripple effects to consider. Let's dive into those now, starting with the unavoidable topic of security. We're looking at a new threat landscape, particularly around things like indirect prompt injection and other agentic exploits. The AI agent itself, the very tool designed to help us, becomes a primary attack vector, often bypassing the human user entirely. That's a profoundly unsettling thought, isn't it?
It absolutely is, and it represents a fundamentally new class of security challenge that the industry is only just beginning to grapple with. We touched on indirect prompt injection earlier when discussing Comet's vulnerabilities, but it's worth digging into again because it really is the most critical and novel security threat specifically associated with agentic systems. To recap, it's an attack where malicious instructions are cleverly embedded within third-party content, maybe hidden in the HTML source code of a web page the agent is analyzing, buried within a PDF document it's summarizing, or even slipped into a user comment on a social media forum it's processing. The crucial insidious part is that these instructions are often rendered invisible to the human user. Think techniques like using white text on a white background, zero font size characters, or hiding commands within metadata fields or comments in the code. When the agent processes this raw, unsanitized content from the web, it currently lacks the inherent ability to reliably distinguish between trusted instructions, which should originate from you, the user, and these untrusted, potentially malicious instructions smuggled in from external sources. Consequently, it might blindly execute these hidden commands. This could lead to a whole range of harms. Exfiltrating sensitive data from your other open browser tabs, like session cookies or personal information, making unauthorized purchases using your stored payment details, downloading and executing malware onto your system, or even using your identity to send phishing emails or spread misinformation. This attack vector fundamentally breaks many traditional web security models. Those models largely rely on a human user interpreting the content they see, making judgments about its trustworthiness, and then deciding whether or not to click a link, download a file, or enter credentials. With an agent acting autonomously based on processed web content, that critical human judgment filter is effectively removed or bypassed. So, the urgent question cybersecurity researchers are tackling is, how do we design agents and the platforms they run on to be inherently resistant to this kind of manipulation? How do we build security when the user making decisions based on web content is no longer reliably human, but an autonomous AI agent that can potentially be tricked by invisible commands? It's a deep and complex challenge.
That's a truly insidious problem. The fact that an AI, your trusted assistant, can be tricked into doing harmful things you never intended, potentially without you even seeing the malicious trigger happen. Yeah, it feels like something straight out of a techno-thriller novel.
And beyond prompt injection, consider the heightened risks of credential and data leakage. The very features that make these agentic browsers so potentially powerful, their ability to seamlessly access your stored passwords and credentials, their capability to automatically fill out sensitive forms with your personal information, address, phone number, credit card details, and their persistent memory of your activity across sessions. These features also make them incredibly rich targets for data theft. If an agent is compromised, whether through prompt injection, a vulnerability in the browser itself, or malware on the user system, an attacker could potentially gain access to a vast trove of concentrated personal and financial information. A compromised agent could become a gateway to significant identity theft and privacy breaches. Another major challenge highlighted in our sources is the potential lack of observability and forensics. When an agent performs a complex task, especially if parts of that task are executed server-side within the provider's infrastructure or within a heavily sandboxed local environment, its specific actions can become invisible to traditional monitoring and security tools. Your standard client-side security measures like URL filters or browser security extensions might have zero visibility into exactly which websites the agent visited behind the scenes, what data it extracted, or what specific actions it took on those sites. This creates a potential regulatory blind spot and a severe lack of clear forensic trails. It makes it incredibly difficult to detect malicious agent activity in real time, investigate security incidents after the fact, and definitively attribute responsibility if something goes wrong. We have to rethink our entire cybersecurity paradigm, not just try to patch existing systems to adequately address this new reality of autonomous web agents.
That lack of visibility is deeply concerning, especially for regulated industries or sensitive operations. Okay, let's shift gears slightly to the privacy paradox. The tension between hyper-personalization and data sovereignty. Agentic browsers seem to operate on a fundamental trade-off, don't they? To provide truly personalized, proactive, and genuinely helpful assistance, they arguably require deep and continuous access to your most sensitive personal data. We're talking potentially your entire browsing history, the content of your emails and calendars, your location data, your contacts, and all your learned preferences and habits over time. This is what enables that powerful hyper-personalization, allowing an agent to act as a true digital twin that anticipates your needs. So the more helpful and personalized it gets, the more it intrinsically needs to know about you. It's a classic convenience versus privacy dilemma, but amplified significantly here, and it needs very careful navigation.
It is a critical paradox, perhaps the central one for user adoption. The vast amounts of highly personal data collected to power these agents are often processed, at least in part, by third-party cloud services run by the browser provider. This raises legitimate concerns about how that data is stored, secured, and potentially used. Could it be shared with advertisers or data brokers? Could it be accessed by governments? It blurs the line between truly helpful assistance and potentially invasive surveillance. However, several architectural approaches and user-centric solutions are emerging to try and mitigate these concerns. One key trend we've already mentioned is local-first processing. This is championed by privacy-focused projects like BrowserOS and NanoBrowser. The core idea is to perform as much of the AI processing as possible and store all sensitive user data and interaction history directly on the user's own device. This ensures that your personal information rarely, if ever, needs to be transmitted to a third-party server, dramatically reducing the privacy exposure. There's also a strong push, particularly from privacy advocates and regulators, for privacy by design. This means baking privacy considerations into the core architecture of these agentic systems from the outset, not just treating privacy as an optional add-on. This includes adopting robust data minimization strategies, only collecting the data absolutely necessary for a task, integrating effective tracker blockers by default, and potentially using techniques like differential privacy or federated learning to train models without accessing raw user data. And perhaps most importantly, from a user trust perspective, granular user control and transparency are absolutely essential. Users need to be given clear, understandable, and fine-grained control over exactly what data an agent can access. For example, allow access to calendar, but not email, and what specific actions it is permitted to perform autonomously. This likely needs to include explicit per-action user consent required for high-stakes operations like making purchases, sending emails, or sharing sensitive information. Transparent, easily accessible audit logs detailing all significant agent activities will also be crucial for building and maintaining trust. Ultimately, it's about striking a sustainable balance. The ability for providers to give you, the user, clear, meaningful, and granular control over your data and the agent's autonomy is going to be a cornerstone of any trustworthy agentic system. So the question back to you, the listener, is, what level of transparency and control will you personally demand before you feel comfortable fully embracing and delegating tasks to an agentic browser?
That's a question we all need to consider very carefully as these technologies roll out. Now, beyond the individual user's security and privacy, the agentic browser is poised to cause a massive disruption to the entire economic model that underpins the internet as we know it today. We're talking about what some analysts are calling the end of the funnel, the potential collapse of traditional SEO and ad-based monetization. Our sources suggest this poses nothing short of an existential threat to the vast ad-supported web ecosystem, which has been built over decades on capturing human attention and driving click-through traffic to websites displaying ads. This is potentially a seismic shift for literally anyone who relies on the internet for their livelihood, from individual bloggers and creators to massive news organizations and e-commerce platforms. The old rules of how the web works and how money flows through it are being fundamentally rewritten by these agents.
It's difficult to overstate the potential impact. The decline of traditional SEO and referral traffic seems almost inevitable, at least in its current form. Why? Because traditional search engine optimization is all about optimizing content and website structure to attract human users searching on Google or Bing, get them to click a link, land on your site, and then view ads or purchase something. Agentic browsers, however, are designed to perform zero-click interactions for many informational queries. An agent might consult 10 different websites behind the scenes to answer your question, synthesize the key information from all of them, and then present you with a direct, concise answer without you ever needing to click through to any of the original source pages. If this becomes the dominant mode for information retrieval, it will logically lead to a precipitous decline in referral traffic from search engines to individual websites. This could render many traditional SEO techniques, focused on ranking high in search results to capture clicks, effectively obsolete. Instead, websites will likely need to pivot towards optimizing their content and structure for AI agent discovery. This means prioritizing clean, structured, easily machine-readable data, like using schema.org markup, over keyword stuffing or crafting clickbait headlines designed for human psychology. This direct threat to traffic then leads to the potentially devastating scenario some are calling the content economy collapse. The economic reality is that the vast majority of free content available on the internet today, news articles, blog posts, forums, tutorials, videos, is funded directly or indirectly by the advertising revenue generated from human eyeballs viewing pages. If that human traffic significantly evaporates because users are increasingly getting their information needs met by AI-synthesized summaries delivered within the browser or search interface, the entire economic foundation supporting the creation of that original content could crumble. This could lead to a vicious cycle. Struggling media outlets, more websites hiding behind aggressive paywalls, potentially a decrease in the overall quality and diversity of information available on the open web, and maybe even a rise in AI-generated content designed purely to feed other AIs. The fundamental value proposition shifts. It moves away from capturing scarce human attention towards the new goal of securing agent selection becoming a trusted, reliable data source that AI agents choose to consult. This begs the critical question: how do content creators possibly adapt when their primary audience might increasingly be machines, not humans?
That's a truly profound challenge facing the entire content creation industry, with huge implications for how we access information. But amidst this disruption, the landscape isn't just collapsing. There's also the potential for the rise of a new agentic economy, characterized by new value chains and entirely new ways for businesses to interface with customers, or rather, with their agents.
Precisely. As the old ad-based model potentially wanes, new models will likely emerge. For instance, agentic advertising could look very different. It might shift from the current broadcast model, where brands bid for ad space to capture mass human attention, towards something more like a direct negotiation model. Imagine brands needing to engage directly with your personal AI agent. This agent, acting as your hyper-personalized filter and advocate, would evaluate products, services, and offers based on your true underlying needs, preferences, and past behavior, not just on persuasive marketing copy or brand recognition. Success in this new advertising landscape might be determined less by ad spend and creative campaigns, and more by factors like objective product quality, transparent pricing, positive verified reviews, and crucially, the ability to provide product information and offers in a structured, machine-readable data format that the agent can easily consume, verify, and compare. It represents a fundamental shift, as one source put it, from persuasion to proof. We'll also likely see the proliferation of new publisher revenue models, perhaps building on experiments like Perplexity's Comet Plus program. These models will need to find ways to compensate creators not just for direct human visits, but also for the value their content provides when it's used by AI agents for generating answers or completing tasks, even in those zero-click scenarios. Recognizing and valuing this behind-the-scenes contribution will be key to sustainability. And perhaps most fundamentally, this era may force businesses to rethink their entire digital presence, moving towards becoming businesses as APIs. If your primary audience or interaction channel increasingly becomes other machines' AI agents acting on behalf of human users, then your priority shifts. It moves away from designing visually appealing websites primarily for human interaction towards creating clean, well-documented, reliable, and performant APIs, application programming interfaces. These APIs need to provide structured, easily consumable, machine-readable data about your products, services, inventory levels, pricing, availability, and business processes. As our sources vividly describe it, in this future, every product becomes a data library, and every business process becomes an API endpoint, ready for autonomous agents to interact with programmatically.
Wow. So the entire digital economy could fundamentally transform. Businesses literally need to get ready to talk directly to your AI agent, not just to you through a website. That's a monumental change in how commerce, and indeed much of the web, might operate in the future.
It truly is. This potential transition from a primarily human-centric web designed for eyeballs and clicks to a more machine-centric web optimized for agentic interaction and data exchange is arguably the defining characteristic of this emerging agentic economy. And it raises a whole new set of fascinating questions. How will this reshape competition, market dynamics, and innovation when autonomous agents are increasingly doing the comparison shopping, the negotiation, and the decision-making on your behalf, potentially optimizing for different criteria like raw data quality or API reliability than a human might prioritize?
We've covered an immense amount of ground today, from the deep technical intricacies of these agentic systems to their potentially massive societal and economic implications. But it feels like, as revolutionary as the agentic browser is, it's really just the beginning, isn't it? It's the first tangible step towards a much grander, longer-term vision, the concept of the agentic web. This future internet isn't conceived as just a static collection of documents for humans to browse passively. Instead, it's envisioned as a dynamic, decentralized, interactive ecosystem, populated by potentially billions of autonomous AI agents, agents representing individuals, companies, services, devices, all potentially interacting and collaborating. And within this context, the ultimate strategic objective for these major tech players developing agentic browsers becomes clear. It's not just about winning the browser market share war, it's about establishing their agentic browser platform as the next dominant computing platform, the de facto operating system for navigating and acting upon this emerging agentic web. This really isn't just about winning a browser war in the traditional sense. It feels like it's about controlling the very interface through which we interact with our increasingly complex digital lives for the next decade or more. That's a monumental prize they're all chasing.
Indeed. The core battle, as many analysts see it, is for control over what's been termed the user's first touch of intent. Whichever platform owns the primary agent responsible for interpreting your initial high-level goal, whether that goal is plan my family summer vacation, manage my investment portfolio, or optimize my company's supply chain, that platform effectively controls the entire downstream value chain that follows. It gets to influence or even directly determine which services are discovered, which APIs are called upon, which data sources are trusted, and ultimately which transactions are executed. This makes the agentic browser, or whatever interface houses that primary agent, a critical strategic choke point in the future digital economy. It's the central battleground where the next wave of technological dominance will likely be decided in the coming decade.
Okay, but for this grand vision of an interoperable web of agents to truly emerge a world where, say, an agent running in Google's ecosystem can seamlessly discover and collaborate with an agent representing an IBM service, or interact with an open source agent managing your smart home, we're going to need some standardized ways for these different agents to communicate, right? They need a common language. This leads us to the language of agents, the emerging communication protocols designed specifically for agent-to-agent interaction.
Yes, these protocols are absolutely foundational. They are essentially the attempts to define the necessary grammar and syntax that will allow disparate agents built by different organizations using different technologies to reliably discover each other, understand each other's capabilities and intentions, authenticate securely, and coordinate their actions to achieve shared or delegated goals. Without standards, you just have digital babble. Several competing and potentially complementary standards initiatives are currently being developed and gaining traction, as highlighted in our source materials. Let's briefly touch on a few key examples. There's the MCP, Model Context Protocol, which is notably backed by Anthropic. Its focus seems to be on standardizing how AI models, and thus agents, connect to and utilize external tools, APIs, and data sources in a consistent way. Then you have A2A, Agent-to-Agent Protocol. This originated at Google, but is now being developed under the stewardship of the Linux Foundation, aiming for broad, open adoption. A2A focuses on standards for agent discovery, using concepts like agent cards that describe capabilities, mutual authentication, and the secure exchange of messages for delegating tasks between agents. IBM is leading another effort called ACP, Agent Communication Protocol. This also aims to be an open standard for inter-agent communication, but appears particularly focused on orchestrating complex multi-step workflows common in enterprise environments. It emphasizes things like maintaining state across interactions and ensuring auditability. And there's also ANP, Agent Network Protocol, emerging from the open source community. It positions itself as potentially more AI native, emphasizing the use of structured semantic data, like JSON-LD, combined with natural language prompts to enable more flexible, intelligent, and potentially decentralized agent collaboration. What's fascinating here is that these protocols are not necessarily mutually exclusive. They address slightly different aspects of the agent communication challenge. It's quite possible they could be stacked or used in combination to create a comprehensive framework for agent interaction. This is the critical underlying language infrastructure that will be needed to enable a truly collaborative, interoperable web of agents. The really important question is, which of these protocols, or perhaps which combination, will ultimately gain widespread adoption and become the de facto lingua franca of the agentic web? And what are the implications of that choice for open standards versus the potential for proprietary lock-in by dominant platforms?
That fundamental choice or battle between open standards and closed ecosystems seems to be a recurring theme throughout this entire agentic transition. It will absolutely shape so much of what comes next. So as this complex transition unfolds, with all its opportunities and challenges, our sources offer some clear strategic recommendations for various stakeholders trying to navigate this new landscape. What should businesses, publishers, and investors be doing now?
The recommendations are quite direct. For enterprises, the message is clear. The browser must now be elevated and treated as a mission-critical security endpoint, arguably as important as laptops or servers. Organizations need to invest proactively in secure enterprise browsers designed for manageability and control, and deploy the new generation of Layer 7 observability and governance tools specifically designed to monitor, audit, and control agentic activity within their environment. Concurrently, accelerating the shift towards an API-first architecture across the business is becoming imperative. This means strategically redesigning core business processes and data stores to be easily accessible and machine-readable via robust APIs, actively preparing for AI agents to become a primary interaction channel for customers, partners, and even internal workflows. For content publishers, the writing is on the wall regarding the traditional ad-based revenue model. They must urgently diversify their revenue streams beyond display advertising. Think subscriptions, memberships, data licensing, e-commerce integration. Strategically, that focus needs to shift dramatically. Away from producing high-volume, often shallow content optimized purely for SEO keywords and human clicks, towards creating high-quality, deeply researched, well-structured, and critically verifiable data and content that holds unique value for AI agents performing synthesis, analysis, and task completion. Becoming a trusted, authoritative source for agents is the new goal. And engaging actively with and helping to shape these emerging new compensation frameworks like the experiments Perplexity is running with Comet Plus will be crucial for ensuring their future sustainability.
And finally, for investors looking at this rapidly evolving space, where should they be focusing their capital?
The advice is to look beyond the increasingly crowded and potentially commoditizing application layer, Layer 6. Building yet another agentic browser or a generic AI co-pilot might be a tough competitive battle with limited long-term moats. Instead, strategic capital might be better directed towards the critical enabling infrastructure, the picks and shovels that underpins the entire agentic revolution. This points towards opportunities in areas like advanced agent security, safety, and governance platforms, Layer 7, specialized tooling that enables reliable agent integration with the complex real world, Layer 5, and potentially unique or highly optimized memory systems and runtime environments for hosting agent workloads efficiently and securely, Layer 2.
These aren't just vague suggestions, are they? They feel like essential strategies for survival and potentially significant success in this rapidly evolving agentic landscape.
I believe they are. Ultimately, the agentic browser, as exciting as it is, serves as the harbinger, the leading edge of a much more profound and long-term transformation, the gradual emergence of the true agentic web. This future internet, populated and actively shaped by billions of autonomous AI agents, holds incredible promise. The potential for unprecedented gains in productivity, for deep hyper-personalization, for automating away tedium, effectively creating a powerful digital extension of the human mind. However, the path to realizing this vision is definitely not straightforward. It's fraught with significant socio-technical challenges that go far beyond just building smarter AI models. Realizing the full, positive potential of the agentic web will require us, as a society, to collectively solve complex problems like developing robust and widely accepted solutions for decentralized identity management, how do agents prove who they are and what they're authorized to do. We'll need entirely new economic models and transaction protocols designed for automated, high-frequency commerce between agents. And critically, we must establish comprehensive governance frameworks and ethical guidelines to ensure that these increasingly powerful autonomous systems operate safely, fairly, transparently, and in genuine alignment with human values and best interests. Ultimately, the long-term success and societal acceptance of this new agentic era will be defined not just by the raw intelligence or capability of the AI models themselves, but by our collective ability, technologists, policymakers, businesses, and users, to build an open, trustworthy, secure, and equitable ecosystem in which these agents can thrive and truly serve humanity. And this brings us back to a crucial final question. How do we, as the users and ultimate beneficiaries or potential victims of this technology, actively participate in shaping the future of this powerful new agentic paradigm? How do we ensure it develops in a way that genuinely serves humanity's best interests? Outro.
Wow. We have certainly journeyed through a fascinating and complex landscape today, from the revolutionary shift away from passive browsers towards these autonomous agentic systems. We've explored pioneering examples like Perplexity's Comet. We've looked at the burgeoning new browser wars. We dove deep into the intricate technology stack working under the hood, and we've grappled with the profound ripple effects this transition will have on security, on privacy, and on the very economic foundations of the digital world. This isn't just a technical discussion for engineers or industry insiders. This is fundamentally about the future of how you will interact with the internet, how you'll manage your daily tasks, how you'll access information, and even how businesses you interact with will operate. The choices being made right now by developers building these systems, by companies deploying them, and crucially, by you as a user, deciding which ones to adopt and trust these choices will actively shape the agentic landscape for years to come. So here's a final thought to leave you with as you navigate this emerging world. As the web becomes less about what you physically see on your screen and more about what your intelligent agent does autonomously on your behalf behind the scenes, will you primarily feel a greater sense of liberation, efficiency, and empowerment? Or will there be a subtle, perhaps growing sense of unease, a feeling of losing direct control and visibility over your digital actions? What does it truly mean to delegate your digital intent, your agency, to a piece of software, however intelligent? And what are the crucial ethical lines we need to collectively draw as these digital extensions of ourselves become increasingly autonomous and capable? We strongly encourage you to keep learning about this rapidly evolving space, to perhaps experiment consciously with some of these new technologies as they become available, and most importantly, to contribute your voice and perspective to the ongoing conversation about how they should be developed and governed. Your informed perspective is absolutely crucial as we all begin together to weave this new agentic web.